relations and functions. And we also explain the difference between domain and range. Again, we'll revise our knowledge on the concept of defined and undefined functions, and then we'll solve general questions in relation to functions. And like I said, it's revision, and so we are going to recap on the things we've learned already and prepare ourselves for the exams. And most of the questions that I'm going to give you here are from the WASI past questions, so they are familiar questions that you have. So let's do some few definition work here, and then we go straight to question and answers. What is a relation? What is a relation? And I'm sure you might have learned this, that relation is a way of connecting two sets, often with a rule. It also can be defined as a set of ordered pairs. And bear in mind that this is also live on Facebook and YouTube as well. So your friends who are far away from home and they don't have their TV set, they can also log in on Facebook, Joy Learning TV, and then Facebook Joy Learning, YouTube Joy Learning TV as well. And they can get access to this lesson live. So let's understand some few concepts about relations as far as this topic is concerned. Now here we have two set pupils and a favorite subject. And we are talking about relations, saying Inshira relate to maybe math, meaning that maybe Inshira likes mathematics so much, that's the favorite subject. And then we can also say that Inshiraba also maybe relate to English, meaning Inshiraba like English so much. And Nyamidie also maybe relate to science, meaning she loves science so much. So that is the relation. Before this day, maybe you might have seen me somewhere and you didn't know me, so you bypass me. But after today, you say, next time you meet me in town, you say, I know this man. Oh, he's the core mass facilitator for Joy Learning. Now there has been a relation. Okay. Now when you see me and maybe you're working with your parent and you say, I do know him, so I know him. He has been teaching core math on Joy Learning. So now the relation has been me, you. Now we have something in common. So that is that. And sometimes with our parents, yes, there's a relation. We have our friends in school, our classmates, there is a relation with them as well. And so we are saying that relation therefore associate the element of one set to the element of another. So let's look at another example here. When we have a set, let's say X, and a set Y, and I relate 1 to 1, and relate 2 to 8, and relate 3 to 27, then the question that I'll ask myself, what is the relationship between 1 to 1, 2 to 8, and 3 to 27? What is the relation? And here you can see that the relation is that if you pick the value X, you cube it and you get the corresponding value Y. Right? So you pick the value S, you cube S, you get the corresponding value of Y. Meaning 1 cube is 1, 2 cube will give you 8, and 3 cube will give you 27. So that is the relation. Okay, that is the relation. And anytime we relate one set to another, we name the main set that is to relate as the domain, and then the set that is receiving becomes the codomain or range. Very soon I will explain the difference between codomain and range. For now I'm just looking at them as the same, but then I will let you understand the difference between the two as well. So let's see. Now we are also saying that relation can also be shown by means of ordered pairs. And so if you look at the example that we saw earlier, Inshira favorite subject is math, then I can say Inshira, math. So I can put that in ordered pair. Then again, I can also relate Inshiraba to English and put that in ordered pair. So Inshiraba, then English. So it means that that relationship can bring them together in terms of ordered pair. Then Nyamidie also can relate to science as well. So this is what we call the ordered pair. And in most cases in relation and function, we'll be seeing a lot of these ordered pairs as sort of examples. All right. So again, we have the second example that we brought in as relations. We saw that 1 maps to 1, 2 maps to 8, and 3 maps to 27. So I can say 1 to 1 and make it 1, 1. Then 2 relate to 8 and so it can be 2 comma then 8 as ordered pair. Then 3 also relate to 27. That also makes it an ordered pair. Now we have types of relations, and that exists a lot in our real life experience. Relations. Today, as I stand here right now, I have a lot of you watching me live. Okay, and so the relationship is me to you. So I'm one person relating to all of you watching me, and all of you also relate to only me as your core math facilitator for Joy Learning. So that is a relation. So you can have a relation, say one-to-many relation, where I relate to all of you, and then many-to-one relation when all of you also relate to me alone as your core math facilitator for Joy Learning. And so types of relation, we can have what we call many-to-many relations. Many-to-many relations. Maybe in your school or in your class, you have a lot of students who are your classmates in that same class. We have teachers who come to your class and teach, then they leave. So you have your maybe science teacher, you have your core math teacher, elective math, you have your geography, you have your chemistry teacher. So many of you, the students, relate to many teachers who come to your class. So that becomes many-to-many relations. And that relation also exists in mathematics. For example, I have a set of x and a set of y. And now let's see, we are saying factors of. So factors of 4, we can think of 4. 1 can be a factor of 4. 2 can be a factor of 4. Okay. And then when I take 6, 3 can be a factor of 6. 6 can also be a factor of 6. And then 1 can also be. So that could be many to 1. And then also many to many, meaning that you can see that 12 also relate to 6, 12 relate to 3, 12 relate to 2, and then 1. And so here we see examples of many to many. So let me go back a bit and let's look at detail. Many to many. That means many relate to many. Okay, so that sort of relationship can exist. Then we have a relationship whereby we have many to 1, like I gave you. Many of you watching me today, I'm the only math or core math facilitator for Joy Learning for this very program, right? So many of you are relating to only one. I mean, I'm the only person you are relating to for now. In terms of our relationship right now, I'm your teacher or facilitator, and you are my student. So that's many to 1. Another example can also be many to 1. Maybe you have siblings, okay, and all of you have only one father. So many of you, one father. Your father becomes, the other side, and many of you relate to one father, or many of you relate to one mother, and that becomes many to 1 relation. And in terms of mathematics, if I have a set of this, maybe I have set x going to relate to set y, and what is the relationship? The relationship is s squared. That means every element in the set x, okay, we square it to get the relation or its corresponding value in terms of y. So 2 squared will give me 4, okay, and negative 2 squared also will give me 4. So many to 1. Then I can say 3 squared is 9, and negative 3 squared also is 9. Because we are preparing for exams, let me bring some few technicalities in mathematics for you to take note of, so that you can prepare yourself very well for your math. Take note that if I write negative 3 squared like this, and I ask you, what is the answer? Probably you may be tempted to pick calculator and then press negative 3, then you press the square. It will surprise you that the answer that will come will be negative 9. Which means negative 3 square written this way will give you negative 9. And that is true. That is very true. But then, if you put it this way, then you get positive 9. So be careful when you are writing negative 3 squared or negative 4 squared or negative number squared. Make sure if you want to say that the two numbers, negative 3 times negative 3, that will give us positive 9. That is this. That is how we write it this way. Right. But if if you write it like this, okay, without a bracket, it simply means you are doing negative into bracket 3 squared. That's what it means. And so calculator understand it that way, and it will square the 3 before attaching the negative. So be careful when you are writing negative numbers and you want to square them. Great. Again, we are looking at types of relations, right? And just for a few things, we are going to learn some few things here, then we will zoom into calculations where we have to look at possible questions that can come as far as WASSCE is concerned. One to many relations. We also have one to many. Your father, okay, is one, and he relates to all of you. I mean, you and your siblings. That is, if you have siblings. Or me standing here, I relate to all my viewers who are watching me live today or this evening. And so that becomes one to many of you. One to many of you. So that is one to many relation. And an example again can be taking square root of a number. So if I have root of 9 can give me 3, and at the same time root of 9 I can also get negative 3. But then I'm looking at x to be any variable or any number, okay, that will be defined when I put it under radical. So I can get root 9 giving me positive 3 or root 9 giving me negative 3. But ideally, take note of this, ideally, square root of any natural number must always give you a positive number, not plus or minus the number. Let me take this opportunity to also explain another error that students often make in class. People make an assumption that if you take square root of a number like 9, it must always give you plus or minus 3. That is not true. Root of 9 is simply 3. But like I said, I'm trying to use this as a variable, and I will explain that to you very soon. See, I'm solving a question. Maybe, let's say I'm dealing with an algebra. In the course of my question, I happen to come across something like this. X squared is equals to 16. And I want to make x the subject. Okay? When I want to make x the subject, it means I'm asking myself, I have a number, I don't know that number. When I square the number, I get 16, right? So what is that number? Then I'm going to say that, okay, per the principles that we use in algebra, I must take square root to both sides. And when I take square root to this and square root to that, I'm going to get x is equal to plus or minus square root of 16. Okay, so there must be plus or minus before the square root comes. Now, why am I saying plus or minus? I'm saying plus or minus because the number we are talking about, I don't know. If the number happened to be 4 and I square it, I'm going to get 16. If the number happened to be negative 4 and I square it, I'm going to get 16. So since I'm not very sure of my answer, I have to show plus or minus root of 16. But the mistake some people make is that they will just say s squared is equals to 16, s is equals to square root of 16. Then from there they will say plus or minus 4. That is not the case. It means you are telling me that if I take square root of 16, I must get either plus or minus. No. And so the plus or minus must come first to show that I'm not sure about what the value of x is. It can be either positive number or negative number. And each of them, when I square, I'll get a 16. That is what normally happens. So let's be very careful when we are dealing with some of these concepts. Okay, especially when we are preparing for exams. Then again, I will say 36 can also, square root of 36 can be either 6 or can be negative 6. And again, my example is very careful. I'm just being careful that I'm using s as any variable at all. That means if I square 6, I'll get 36. And if I square negative 6, so I'll get 36 as well. Okay, then the fourth type of relation is called one-to-one relation. One-to-one relation. Okay, so one-to-one relation, what are we talking about? We're talking about one person knowing only one person. Okay, one-to-one relation, one person knowing only one person. or let me say, your father has only one wife, your mother, and so the relationship is one-to-one, one wife, one husband, right? Perfect. Okay, that is one-to-one, right? So in mathematics, you also can create one-to-one relation. Let's say I have a function called x, or sorry, a relation called, because we're not talking about function yet, talking about relations. Relation called s squared plus 4. They relate. And so if they relate and I put s as 1, then I square 1 plus 4 will give me 5. And that will be only 5. If I square 1 plus 4, I can't get more than one answer. I'll get only one answer. Then if I square 2, okay, and I add 4 to it, I'll get only one response, which is 8. The same thing applies to 6, 3, and then 4. So this is what we call one-to-one relation. One-to-one relations, right? Then let's mention mapping shortly. Then we go to functions, and then we take questions that are likely questions that will come as far as WASSCE is concerned. So mapping, what is mapping? Mapping, you see, is more or less like relation, right? But then we are saying mapping is a relation which maps elements in one set to a unique element in another set. That means mapping is specific. One set to a unique element in another set. Mapping is the same as function. When we talk of function, we will come back and refer to function, and they are the same. Okay, so again, we say that from this definition we've already established, from this definition, when we said mapping is a relation which maps elements in one set to a unique element in another set, then we are saying that if that is true, then from this definition we can say one-to-one relations and many-to-one relations are mapping. Let's explain. One-to-one relation means I have one element in the set mapping to only one element in the codomain or the range. Only one unique husband. You understand? So that makes it many to one, and that is accepted by mapping. So mapping can say many to one or one to one. Beautiful. Now that is just fundamentals to help us understand the concept of relations and functions. Now let's talk about functions, the most interesting part of all, because that is where we anticipate a lot of questions to come our way as far as this course is concerned. Now, what is a function? A function in mathematics is a relationship. That is number one. It's a relationship. It's a relation, like we said, father, mother, husband, wife, children, father, student, teachers, student. I mean, that relation. In mathematics, we have relations, and we are saying the function is a relation explaining how two variables are related to each other. Okay, how two variables are related to each other. That is what we call functions. But take note, all functions are relations, but not all relations are functions. We'll come to that aspect very soon. So a typical example of a function is vending machine. Now in vending machine, we have two relations here. We have the input and we have the output. Right. So when you see the machine serves as a relation or a function. Now the machine accepts input by you putting in a coin or a particular denomination which has been defined. Okay. Now when you put in that denomination into the machine, then the machine processes the denomination to relate it to the input that was put in and say, okay, per this input you've put in, then this is how it's going to relate. That's how it's going to function. This is going to be your output. Then it will drop maybe a product for you. So that if the product is supposed to be a kind of Coke that you want to buy, then the machine accepts your input, process it, and bring you the output, which is the Coca-Cola. And if it's a biscuit you want, machine accepts your input, process it, and give you the output. So we are talking about two variables here, the input variable and then the output variable. And what is relating them, what is making them come together or process them is the machine. Okay, so the machine is a function of your money, and then the outcome becomes the product that comes out from the machine. So a typical example of a function is the vending machine. Then again, we have ATM machine also serve as a function because it takes your card. So there is a function of your card, and the card has got some rules, right? So the card goes into the machine has set the card per particular rule, and then per the input of the figure that you put in after bringing in your card, the machine now process the input, relate it to something in the machine, and bring out something for you to go with. That is the cash, and that is another typical example of a function. So function relate two variables when one affect the other or one depend on the other. That is function, and that's what we are going to look at. Another example of function in real life experience is taking your weight. Now you can see that as you stand on the scale, you now make an input. The weight goes into it. The machine now process your weight and say, hey, Master, you are too heavy. Your weight should be maybe 590 newtons, or in terms of kilogram, I would say 59 kilograms because you are too heavy. I think the last time I checked my weight, I'm supposed to be around, I'm not very sure, about 59 or something. And that's not bad. Okay, so that is a function. So the machine accepts my weight and then process it and give me an output of the mass, or in terms of the mass, or in terms of the force, either newtons, or but normally the scales that we use always gives us the mass. Okay, so that we can convert that to get our another function. Also is this. In fact, I love this when I'm teaching function because it really explains the concept of function. Look at this. This you look at it, we say nika, right? Or the cornmeal machine. Now see what happens. The cornmeal machine accepts input. That is the grains of the corn or the maize. And then the machine processes the corn and gives out a powdered form. That is the output. And so that is the function. So the function of the grains goes into the machine to produce the powdered form. So we'll revisit this particular machine again to explain the difference between domain and codomain and range, and that of why we say some functions are defined, others are not defined, depending on the range that is given. So in the mathematical definition, in the more detailed work, we can say a function is a relation between a set of inputs and a set of outputs with the property that each input is related to exactly one output. When you put in your ATM card, slot your ATM card into the machine, and you enter your code, everything, and you enter 500 Ghana cedis. That is the input of 500. The machine will process and give you an equivalent amount of 500 Ghana cedis in cash. It will not give you 500 Ghana cedis and give you 200 Ghana cedis and give you 300 Ghana cedis because you enter only 500 Ghana cedis. No. When that happens, then it's going to be one-to-many relation, which is not accepted by the machine. Okay, well, that is not accepted by function as well. And so function must have one input with relate to one output. A function is like a number machine again. An input x could be transformed into a corresponding output y. Now look at a normal machine like this, a machine of this sort, okay? And I'm going to make an input. This is the machine. The machine is this big thing, but then within the machine, this is the function that we are looking at. Okay, that is y is equals to 3s minus 2. And so what I'm going to do is that I'll put in a number. Let's say number 4. Number 4 is going to the machine, and then the machine will process the number 4. Number 4 is X input. 4 is entering into the machine. Whenever I see X in the machine, I'll let 4 replace the X. So I'll multiply 3 times the 4 minus 2, and then it will bring me an output Y, which will be 10. Okay, that is 3 times 4 is 12 minus 2, 10. So I get the output. So the function now becomes 3x minus 2. The input is 4, the output is 10. Again, I put in, let's say, a number. Let's put a number 5 into the machine. The machine process this and say, okay. I can multiply 3 times the 5 minus 2, and this is my output 13. That is function. Very beautiful, right? Very, very easy topic too. I love function because, you see, in exams, any question that comes your way, as far as what is concerned, trust me, you can do it within a twinkle of an eye. I mean, you don't need to struggle so much to get an answer. So, when we put in all these numbers, 1, 2, 3, 4, 5, 6, 7, up to infinity, we can process and get all this number. 1 goes into it, it gets us 1, 2 gives us 4, 3 gives us 7, 4 gives us 10, 5, 13, and so on and so forth. And that can continue on and on and on. So we are saying the input gives us the domain. Now we are bringing the terminologies, right? Good. The input is what you call the domain. So the corn that goes into the corn mill machine becomes our domain. Then the relationship. Okay, what happened in the machine? What happened in the machine? The relationship of the rules and then the regulations that was set into the machine to grind the maize is our function. Then what we get out becomes our range or image. Okay, now initially we're talking about codomain and we talk about domain. Let me quickly explain that. If I have 2, 3, 4 in the set domain, and I have 4, 6, 8, 10 as my other set, which I will call the codomain. But then I can relate 2 to 4, meaning 2 times 2 is 4. 3 can relate to 6, meaning 2 times 3 is 6. 4 can relate to 8, means 4 times 2 is 8. But then there's no number mapping to 10. Now the whole of these numbers here in this set is called codomain. Codomain, okay? But then the ones that the element in X is mapping onto, which is the 4, 6, and 8, are called the range. Okay, so all the elements in here are the codomain, but the ones that are having direct relationship are called the range. And so the difference between range and codomain is that I can say all elements in the Y can be codomain, but the only element that the S is mapping onto becomes the range. I hope that is clear. And so we can say that range is a subset of codomain. And in some cases too, all the elements in the codomain can be the same as all elements in the range. When that happens, then the two become the same. Right. Okay, so what is domain? Now we are bringing terminologies that is going to lead us to solving questions. What is domain? The domain of a function is a set of possible values of X which make the function defined. Simple. Now, let's understand this with real life experience. I have corn mill machine. Then I go and pick stones that are of the same size as the corn. And I pick number of them. Then I say, oh, because they are of the same size, let me pour that into the machine. What do you think will happen to the machine? Your guess is good as mine. It was small because originally that machine wasn't meant for grinding stones. It was meant for corn or something similar to. And so we'll say that if I put stones cannot be defined as domain because they can't be the right input. And so they'll make the function undefined. They'll make it spoil. I mean, it will spoil. It will be undefined. It will not work. It will not function. Okay, but if you put the corn in there rather, then the corn becomes the rightful material that can go into the machine. Then corn become the domain, because the system accepts it and gives you an output. And so a situation whereby the element that goes into the machine cannot give you output, then that element will not be called domain. So domain are all elements that goes into the function and make the function possible or defined, so it can give you a possible output. Then a range. What is range? Range of a function is a set of all possible values of y that makes the function also defined. That means those numbers that comes out of the machine, they also are the correct word that make the function defined. That means they are the response to the input. That is, or the output. They are the response to the input, so they form the output. Good. So let's look at types of functions as compared to types of relations. We saw 4 types of relations. We are going to look at types of functions. Then we have, as far as core maths is concerned, because we have other types that we will not mention them here. So for you math students, if I don't mention the ones that you know, don't think this is the limited types of functions. We have other ones that will not mention. So we have one-to-one function or one-to-one functions. Now we're saying that function says that input, then one output. So a function is said to be one-to-one if the element in each element in the domain has only one image in the codomain. That makes it one-to-one. So you can see the example here is one-to-one. Then another example is here. Now look at example 1 and example 2. Compare the two and see, and tell me whether they are the same or whether they will define function. If you look at the first example, that is this one, you see that we have 2 elements that are relating to 1. In mapping, we'll call it many to 1. And many to 1 is okay for mapping, but it's not okay for function, because 4 has an image of 5. The same the same image 5 has a domain of 11, which makes it not to be defined as a function. Then we have one-to-one function. Okay, one-to-one function. Even though this is a function, all right, let me say that's a function, but it's not one-to-one because it is many to 1, but not one-to-one. And this one is one-to-one function. At the same time, it can also be a function as well. So that is that. Then we have many to 1 function, like we said it earlier on. That can also define function. It defines mapping, define function, but it is not one-to-one. So this is an example of many to 1 function. That means each of these elements, they have unique images, so that makes them a function, and it is many to 1. Another example 2 is here. You can see -1 relate to 2, +1 also relate to 2. So like I gave you example, if your father has 2 wives, your father having 2 wives, that is his relation with your mother and your stepmother, is not a function. But if you go the other way around and there is a many wives to 1 husband, that one is a function, because if you ask each of the wives, they will mention only 1 husband and a unique husband. That is that. Then another example 2 is many to 1 over here as well. Now let's take a few examples. Now questions start from here. Few example, then we will look at the defined and undefined function. Right. So look at this question here. A function is defined as j of x. In some cases, you see that it will be written like this, j of x. And normally when we write j of x this way, we use equal to show it. But when we make it j of x this way, we use arrow to represent that. So a function g of x is equal to x squared plus 1 is defined on the domain -1, 0, 1, and 2. Find the range of the function, right? So here we are having this as a machine, and then we are going to put in all these elements into the machine. Now the question is, will all these elements go through the machine and gives us the output? Those ones that can bring the output, they will be defined as the range. So we'll start one after the other. So the function g of x is equals to x squared plus 1. So when I put in -1 into the machine, whatever I see as is going to be -1. So I'm going to have -1 squared. See, I've put the bracket plus 1. Then I simplify this, and that gives me -1 squared plus 1. So we have 2. Right. Then I put in g of 0. Then I process it. So I'm going to process it, like I said, it's a machine. So I'm processing it. So it's going to be 0 squared plus 1, and that will give me 1. Then I put in g of +1, and that will give me 1 squared plus 1. Answer will be 2. Then I'm going to have g of 2. Also, I'm going to have 2 squared plus 1. Answer gives me 5. So the range, okay, first we had 2, we have 1, we have 2 again, and we have 5. And you can see that some of them are repeating, so we don't repeat them. So this will not be the final answer, but then rearranging them and then cancel out the repetition, we are going to talk of 1, 2, and then 5. But then when you have to put this in a set form, or diagrammatical form, of course, let me clean this part so that we show that aspect. If I'm going to use diagram to represent it, this is how it's going to be. This is how it's going to be. I'm going to have my domain as neg1, 0, 1, 2, and have my range also 1, 2, 5. Now I will map -1. -1 gave me 2, so I'll map -1 to 2 like this, and 0 gave me 1, so 0 will go to 1, and +1 also gave me 2, so it will go this way. All right, and then 2 gave me 5, and 2 go that way. So this is how it's going to look like. Okay, but then we can write this as our answer, but in reality we have only 3 elements within the range, because 2 is repeating. So we can see that element 1 and -1, each of them map to 2, and that becomes the solution to the question. Right. Now let's take another example. A function is defined as f of x is equals to that. That is the machine. We want to find the images. When I put in 2 into this machine, what should come out? If I put in 3 into the machine, what should come out? Very simple. So that is our image. So f of x, that means the machine is defined as a function of x. So that gives us 2x plus 2, x minus 1. Now they are telling you, when you put in any element, this is how the machine is going to process it and bring you the output. So if you put in 2, if you say f of 2, let me clean this one and write it well. F of 2, that means you are entering the machine with 2. It's like you punch 2 CDs with your ATM card. You don't expect to get 5 CDs, right? It will come out with its equivalency. It will process with the rule per your account number, per the money you have in your account, and it will give you the output. So when I put in 2, according to this, maybe it can be a game of chance. Put in 2 and let's see what number you get. So whenever I see S, I put 2 there. So I'm going to have 2 times 2 plus 2 here, all divided by 2 minus 1. That means whenever I see 2 S, I put 2 there. And let's process it and see. 4 times 2, 6, divided by 2 minus 1, 1. Answer, 6. It means when you put in 2, you get 6. I wish that should be a machine that will be around. Like when you put in 2 series, they'll give you 6 series. That would have been very nice. So, so maybe you can put in a machine, a function that anybody who put in maybe a particular money, the amount to be times 3, and then you get it back. That would be nice. Well, that's just by the way. Now let's also say, what is f of 3? What is f of 3 according to the question? We have 2 times 3 plus 2. That means whatever I see as I put 2 there, 3 there, all divided by 3 minus 1. Once again, I do the simplification. 2 times 3 is 6 plus 2. I get 8. Then at the denominator side, we have negative 3 minus 1, and that will give us 2. And so finally, we get our answer to be 4. That means the function of 3, the output is 4. Now you see the domain and you see the codomain. It makes sense, right? Good. Very soon, we'll go for a break and I'll show you, I'll give you the opportunity to come out with answers to some of the questions I'm going to put across for you. Right. So let's take another question here. A function is defined as x squared minus 3. What is the domain of this function? What is the domain of this function? It's more or less I'm asking you a simple question. What are numbers that can go into this machine and it will possibly give out output? That is what the domain is. The question is asking you. So the domain means all elements of x that goes into the function and make it defined. That means to come out with an output. If a number can go into it and it will not bring any output, then that number cannot be a domain. We said that earlier. Any number that will go into the machine that will not bring output, that number will cease to be a domain. All elements that goes in and bring output are called the domain. I hope it's clear. Beautiful. So what are the elements that can go into this machine and give us output? If we think a little bit about this, and let's see. Okay, it's not time to call in yet. We'll give you the time to call, but now just think about it and see. Put in any number into x and let's see whether we can get an output. Be in a rational number, be in irrational number, be in natural number, counting numbers, integers, whole numbers. You realize that any number you put in there, you get an output. Any number. So far the thing is a number, you get an output. Or let me say any real number, because if I don't take care, people start thinking about imaginary number. It is senior high school math. So if I say any number, we are referring to real numbers, because we don't do complex numbers in core math. So we assume you don't know, even though it's there. We assume you don't know. So any number here, I'm referring to all real numbers. So if I put in all real numbers, so I will say S such that S can take all real numbers, can belong to all real numbers, because any real number, when I put that number into X and subtract 3 from 8, I will get an answer. And so the domain is going to be a set of all real numbers. Because this is a revision show, maybe you have to review a little bit about what real numbers are, because I know some of you, you did it in Form 1, right? And you might have forgotten what a real number is. We have numbers like natural numbers or counting numbers. They are numbers that we used to count, like 1, 2, 3, 4 to infinity. They are natural numbers. In that case, negative is not part. You understand? Then, if we bring 0 to natural numbers, it creates another set of numbers. We say, so if this is your natural numbers, okay, and you introduce 0, 1, 2, 3, 4 to infinity, then we get a new set of numbers called whole numbers. I'm saying this because a time will come, you need to understand this very well. Whole numbers. Then when we introduce negative, like -3, -2, maybe here we are talking about numbers to infinity, okay? So let me take this one off and say numbers to infinity. That means from negative infinity up to -3, -2, -1, 0, 1, 2, also to infinity. Right, all these numbers, bringing in 0 and negative numbers and positive numbers gives us integers. And so -2.5, is it an integer? It's not, because it is not a whole number. And we are saying integers are positive and negative whole numbers. Okay, so 2.5 is not an integer because it's not a whole number. Half is not an integer, it's not a whole number. Then when we bring this half, 2.5, all the decimal values into this existing set of integers, then we create another number called rational numbers. So rational numbers are numbers comprising of fractions, decimals, okay, whether recurring decimal or terminating decimals, whole numbers, integers, natural numbers. They are all together forms rational numbers. Then we have some set of numbers, for them, they are dangerous. For example, square root of 2 is a number. If I ask you to give me square root of 2, you start today, I'll end this lesson, go and sleep. Tomorrow morning, you'll still be mentioning the number root of 2. The next 3 years, you'll be mentioning the number. You keep mentioning it, it will never stop, it will never terminate, it will never recur. It will go on and on till thy kingdom come. If you are mentioning such number and someone comes closer and then what you mention, the person go home and come back and you are mentioning number, he will think you are out of your mind. I mean, you are not being rational. I mean, you are insane, or you are growing mad or something. I mean, it doesn't make sense. How can you mention a number that you mentioned it for the next 20 years, you still be mentioning the number? I mean, it doesn't make sense. So such numbers, we call them irrational. They don't make sense. They don't terminate. They don't repeat. They go on and on and on and on and on till thy kingdom come. We call them irrational numbers. Example is root 2, root 8, 3 root 4. 3 root 5. Root 4 will not be a rational number. It will be a rational number. So 3 root 5 is irrational number. Pi, almighty pi, also is an irrational number. Right. So these are what you call irrational numbers. Now, when we bring all these irrational numbers together with the rational numbers, then we create what we call real numbers. And the real numbers, we always use capital R to represent them. And that is why we are saying that. So real numbers comprise of all the rational numbers and all the irrational numbers, so that if we are saying the domain of this function, we are looking at a set of numbers, a big range of numbers that will satisfy this particular statement. And each of these numbers we've mentioned, when you put it into this particular function, it will give you an output. And so we are saying the domain is going to be all S, such that S is member of all real numbers. There's no an exception. I mean, there's no exception to this. There's no exception to this. Now, another set of questions we have here. Okay, let's look at it. A function is defined as f of s maps to as plus b is such that f of 1 is 9, f of 2 is 14. Find the values of a and b. Then 2, want to find the values of f of 1, f of 0, and f of -2. So look at the question. We have a function is defined as f of x, and the function is ax plus b. That means that is the machine. And when they put 1 into the machine, the output came as 9. When they put 2 into the machine, the output came as 14. So when they put 1, that means I replace s by 1, the result gave me 9. That means A times 1 is A plus B is equals to 9. Then they put in another, that is this one, 2 into the machine. That means A times 2 plus B, the result came as 14. That means we are saying 2 times A is 2A plus B is equals to 14. Let's call this equation 1. Let's call this equation 2. We want to know the real function, so we can use it to solve other functions. So let's call it equation 1, equation 2. Then we solve them simultaneously. So they are not doing simultaneous equation, but I'm sure you might have done it in SHS 1 and 2. And even JHS 1, yes. And JHS 2, you did it. Even 3, you did it. So it's there. But maybe one of the days we'll come and then talk about it detailed. So solving them simultaneously, we can use the elimination method by saying subtract equation. Let me write them here so they can see the clear picture, because we are doing revision. Let's try to revise very well. So I can subtract equation 1 from equation 2, or equation 2 from equation 1, so that I can eliminate the b. So subtract equation 1 from equation 2. That means I will do 2a minus a will give me a. Then plus b minus b will give me 0. Then is equals to 14 minus 9 will give me 5. All right. So that my a becomes 5. Now that I know my a to be 5, I can use it to find for my b. I can put it into any of the equation, maybe equation 2. So I'll say 2 into bracket 5 plus b equals 14. Now b becomes 14 minus 2 times 5 is 10, so minus the 10. And when you subtract, you get b to be equals to 4. So my a is 5 and my b is 4. So the function or the machine cannot be written as f of x is equals to a is 5, so 5x plus b, and b is 4. So this is the function. This is the machine now. Very clear. That's the machine. Now, if that is the machine, what is f of negative 1? That means now when we put negative 1 into that machine, what will be the outcome? Have you seen it? Very simple. You see, function is a very wonderful topic. Some of you might have run away from the class saying that I don't like maths, I don't like functions, but it's one of the easiest topic you can handle as far as core maths is concerned. And so now we are going to use this to answer the second, third, and fourth. I think this should have been 3 here. Let me do that correction quickly. This should be 3. Question 3. So because this is question 1. This question 1, this question 2, this question 3, and then question 4 rather is this one. So IV 4, right? Sorry for that error typed. Right. So let me clean this part so that we can do the remaining part of the question, which is to find f of negative 1. Okay, so the machine is f of x equals 5x plus 4. Now I want to put in negative 1 into the machine. Whatever I see that I put negative 1, and when I process it, I'm going to get negative 5 plus 4. Then I get my f of 1 to be neg 1. Oh, so I put in negative 1 and I get negative 1. Garbage in, garbage out. Okay, let's put in 0 and c. So f of 0 also will give us 5 times 0 plus 4. That rather is not giving us 0, surprisingly. So the answer is 4. So f of 0 is 4. Right. Then what is f of negative 2? That also be 5 times neg 2 plus 4. And we get neg 10 plus 4. And we will get negative 6. So it means we put in negative 2, we get negative 6. That is beautiful. That is very, very beautiful. Okay, so that answers example number 4. Okay, so these are the answers we had. Then we are going to do defined and undefined terms. Before we continue with this, we'll go for a short break. Then when we come back, after explaining this concept, I'll solve one example. Then I'll give you chance to solve or to give me answers to the rest of the questions. Then I will tell you when to bring your answers to the problem of the day. So stay tuned and let's go for break.
Examination malpractice is any form of deliberate cheating on examinations which provides one or more candidates with an unfair advantage or disadvantage. It is an illegal act and can be perpetrated by a single individual or groups. It can occur outside or inside the classroom. So before you enter the exam hall, make sure you follow these instructions. 1. Empty your pockets and avoid entering with a foreign material. That is smuggling of answer scripts. 2. Avoid writing on sheets of papers, handkerchiefs, erasers, covers of calculators, and on the skin. Remember not to fall victim to any examination malpractices so you could have a peaceful examination. Prepare well, and we wish you all the best. Joy Learning. Keep learning. Examination malpractice is any form of deliberate cheating on examinations which provides one or more candidates with an unfair advantage or disadvantage. It is an illegal act and can be perpetrated by a single individual or groups. It can occur outside or inside the classroom. So before you enter the exam hall, make sure you follow these instructions. 1. Empty your pockets and avoid entering with a foreign material, that is smuggling of answer scripts. 2. Avoid writing on sheets of papers, handkerchiefs, erasers, covers of calculators, and on the skin. Remember not to fall victim to any examination malpractices so you could have a peaceful examination. Prepare well, and we wish you all the best. Joy Learning, keep learning.
Looking for a new way to revise for your WASI? Then Joy Learning has everything you need in place. Yes, we are back with the 2023 revision show for SHS 3 learners. Don't worry, your favorite question of the day section wasn't left out. And you can engage with your facilitators during live TV lessons, ask questions, and get real-time feedback in the comfort of your own space. The 2023 revision show for SHS learners shows every Monday to Friday at 7:30 p.m. right here on Joy Learning. Starting Tuesday, 2nd May 2023 at 7:30 p.m. Joy Learning. Learning is so fun. Joy Learning. Keep learning.
You're welcome back. We are still on SHS Revision show on Joy Learning, and this program is designed especially for the final year students who are writing this year's WASI, and it's going to run through from this time to the time that you finish with your WASI, and every day, Monday to Friday, 7:30 p.m. you'll be watching this live, and it's so live that you can call in and ask your question, interact with us. So today we are looking at core mathematics. And we've been looking at the topic relations and functions. We've gone through the definitions. We've seen some few terminologies. We've been able to explain what a function is. It's like a machine or anything that has set input, process, and give you output. It's a relationship between an input and output, and the machine is within. That is the function. And we've been able to talk about domain and then the range. And we want to continue. We are looking at defined and undefined functions. And let me also remind you that this program is live on Facebook and YouTube as well. When you go to Joy Learning TV on Facebook or Joy Learning TV on YouTube, you get it live. So those who are not in the house and they think they are missing, just inform them. They just get their phones, and then log in, and they'll be able to get this live. Okay, so very soon I'll give you a chance to bring your questions, but let's explain something very, very important. Defined and undefined terms. I'm going to teach you something that you shouldn't forget. It will help you to do so many things. Even elective maths, you need this concept I'm going to explain here. Very, very important. So pay attention very well. Get your notebook, your calculator, everything, and let's go. Now, when do we say a function is defined and when do we say a function is undefined or not defined? Let's take it from here. Now, let's have a number like let's say 100 divided by 4, a fraction like this. We know 100 divided by 4 should give us 25. Now, we have the top number as the dividend. This is called divisor, and this is our quotient. Now, anytime you divide the dividend by the divisor and you get a quotient, there is another relationship here. If I multiply the divisor by the quotient, I should get the dividend or the numerator. Again, let's have maybe 25 divided by 5 and the result is 5. 5 times 5 here should give me 25. It's true. If you do polynomials in elective maths, you will understand this better. I mean, we have a concept we say dividend over divisor is equals to quotient, and if there's a remainder, it will be plus remainder over the divisor. And so again, if I say 8 divided by 2, I will get 4. That means if I multiply this divisor by the quotient, it should give me back my dividend. And this is proven, it's true. Beautiful. Now, if it is true, then again, what if I have 8, let me say, if I have 0 divided by a number, let's say 8, what should be the answer? I'm sure you tell me the answer is 0. Don't say it's 8. I'm begging you. The answer will be 0. Okay, let's say if it is 0, fine. 8 times 0 will give me 0, which is perfect. And if you think the answer is 8, let's put 8 here. 8 times 8 should be 64, but that is not 0. You see, so it means that the answer for this cannot be 8, but rather it should be 0. And the confirmation is that it's 0 because 0 times the 8 here should give me back a 0. And that is also perfect. And it's true. Now let's do another one. Let's have a number, maybe any number at all, 25 divided by 0. What should be the answer? Maybe you say, okay, the answer is going to be 25 because 0 divided by, 25 divided by 0, the 0 is nothing, so the answer should be 25. So let me put 25 here first. So if it is 25, fair enough, okay, then it means per the theorem we are trying to establish, that means this also times this must give us the 25 back. 0 times 25, will it give me 25? No, it's not going to give me 25. You see, it's so real. 0 times this will never give me 25. 0 times 25 will give me 0. So it means putting 25 here will not work. Okay, if it will not work, let's take it away. What number will make it work? I can hear somebody saying, then it's 0. Okay, let's put 0 here. 25 divided by 0 is 0. 0 times 0 is 25. No, it's not possible. So it means it's not 0 2. Hey, so if it is not 0, then what should be the answer? A number divided by a number. This is 25 divided by 0, and we are not getting any answer. What number can we put here? Okay, let's put 1 there. Let's put 1. It's 1. 1 times 0 is not 25. Yeah. We put 4. 4 times 0 is not that. So what number will come here? No number. So we say it is undefined. Because we can't define it. Not only 25. Put any number at all. Maybe negative 13 divided by 0. Any number you try to put here will never work. You put 0 there, it won't work. You put negative 13 there, it won't work. You put 1 there, it won't work. So what number will make it work? We say it is undefined. Means we can't define it. You can't put any number there, so we call it undefined. That is why most cases when you are solving questions in math, they will tell you where the denominator is not equal to 0. They will say maybe A over B, then they'll make a condition B is not equal to 0. The moment B becomes 0, the whole thing becomes undefined. The machine will not work. Okay, so that is what comes with the word undefined in fraction. We are going to carry the same concept into functions as well. Again, let's see. Let's have functions. Let's say I give you a function. The function is 2x squared minus. Okay, let me just do a simple function. This is too complicated. Let me use a very simple example to make it work. Let's say 2x minus 4 divided by x minus or s plus 3. It's a function. Okay? And if it's a function, then every element I put in there, it must give me an output. So that I can call it a domain. Any domain that goes into it must give me an output. So I'm going to put a number. Let's put a number like 2. So when you put 2 in, you are going to get 2 times 2 minus 4 divided by 2 minus or plus 3. And that will give us 4 minus 4, 0 over 5. And the answer is 0. We've said that already, so it will be 0. So it means f of 2 give me 0. That means 2 is a domain. Agreed? Agreed. Let's pick another number. Example again, let's pick number like f of negative 3 into the function. Let's see what will happen. 2 times negative 3 minus 4 divided by negative 3 plus 3. What is the answer here? Negative 3 times 2 will give us negative 6 minus 4 will give us negative 10 divided by 0. Ha, wahala. Negative 10 divided by 0, what is the answer? Undefined. So this negative 3 cannot be called domain to this function. It's wahala. It will enter. It will never go into. It's like you putting stones into the cornmeal machine. It will never go. I mean, it won't work. It will spoil the machine. So the negative 3 become a number that will make the function undefined, because we are getting undefined here. Does it make sense? So a number that will make the function undefined will not be called domain. Agreed? Perfect. So we can only get domain when those numbers that goes into the function will come out with an output. When we put negative 3 into the machine, what are we getting here? Undefined. No number is coming out. So negative 3, go away. We don't need you because you are making the function undefined. So you become an exception to all numbers. We don't want you because you made the function undefined. And so here our work is to fish out numbers that will make the function undefined, so that when we are stating our domain, we can say maybe all real numbers except this number. Take it out. The rest, yes, because they can go in and bring us output. If I can put my Ghana card into ATM machine and get money, then no wahala. Nobody will work, because Ghanaians, most of us have Ghana card. We go and stand at the ATM, we slot our Ghana card, money flows. Oh, that would be good news. But try it tomorrow. You'll be in trouble. The next moment you find yourself in the police custody, because the machine doesn't accept Ghana card to bring in or give it access to make an input to get an output. So the negative 3 here is becoming a Ghana card operating ATM machine. But we have cards that look the same size as Ghana card that accept, that goes into the machine accepts it and give us output. So it doesn't mean negative 3 must always be making a function undefined, but this very function negative 3 doesn't accept or doesn't go into it. And so what are domain and what are range, what are elements that make the function defined, and the ones that will make it undefined? So my first question for you is this. A function is defined as f of s equals 2x squared minus 2. Hey, it's like the example that I give, almost the same, well, a bit different. X minus 3. What is the domain of this function? The moment I ask you this question, I'm asking you, what are the elements that make the function defined? Period. Defined. What are the elements that make it defined? So, okay, let's put in 2, yeah, it will work. Let's put in 4, yeah, it will work. Let's put in 1, it will work. Let's put in 0, let's put in square root of, it will work. But there will be a number that when you put in, it won't work. How do we fish out the number? And this is what you're going to do. First of all, I'll ask myself, could there be a way that this fraction or function can be undefined? That can only happen if the denominator becomes 0. Hello? It's clear, right? Very beautiful. I love maths, and I know you love maths too, because it's very easy to handle. The function can be undefined if the denominator becomes 0. For that matter, there shouldn't be negative, or sorry, there shouldn't be any number down there to become 0. So what we are going to do is that we will say for the function to be undefined, okay, to be undefined, x minus 3 should be equal to 0. Do you agree? Yeah, because it is when the denominator becomes 0, then we say it's undefined. So if it's undefined, then x minus 3 being the denominator must be equal to 0. That is the only condition that will make it undefined. So if it is equal to 0, what is x here? We calculate for x, and x will give us 3. Oh, that means when you put in 3 into the function, no output. Perfect, right? No output. So we'll say that if 3 is making it undefined, then let's put aside. Could it be net number? No number will make it undefined again apart from 3. So we'll say that, okay, then our domain is going to be s such that x is member of all real numbers except 3. Simple. That means any number can flow. Enter, give us output. Enter, give us output. Only 3 goes in, it will give us undefined. So we take it out and say except 3, all numbers will make it defined. And that becomes your answer. So this is your domain. That means these are the elements that goes into the machine and bring out output. And that answers the question, the domain, the range of values of x that will enter to give you an output, except 3. Somebody can write this same statement as s such that s member of all real numbers, s is not equal to 3. S is not equal to 3. That means the moment s become 3, there's wahala. So s is not equal to 3. So you can write this as your domain, and you can write this as your domain. Whichever way you go, you get your answer right. You get your answer right. Good. Now let's take another example. Then I'm going to give you the opportunity to answer the rest of my questions. Get ready with your phone. I'll give you the line very, very soon. Let's go through this one. Find the values of x for which the function f of x is defined. And here it's like I'm saying domain, because the ones that will make it defined are the domain. So more or less I'm asking you for domain, but I won't say domain. I will say what are the values of x that will make the function defined. So let's see the ones that will make the function defined. Let's go. So we are going to ask ourselves, okay, then what to make it undefined? So that we can take it out. Then we can now say all numbers. So for the function to be undefined, okay, because we need a defined, we have to take out the undefined one before we can now generalize the defined. So for it to become undefined, then our s minus 1, which is the denominator, should be equal to 0. That will make it undefined. So if it is 0, then what is our x? When you simplify this, you get s to be 1. That means the moment I put 1 into this function, I'll get undefined. And it's true, because when I put 1 here, I'll get 2 times 1 plus 2 over x1 minus 1. Answer, I will get 4 divided by 0. And the answer will be undefined. So I would therefore say that, okay, then it means for me to state all the elements of x that will make the function define, it to be s such that s members of all real numbers except s is equals to 1, or s should not be equal to 1. And that becomes the answer. Now question number 3, number 4, number 5, up to where we'll look at the question of the day, I can give you the opportunity to call in and I'll bring your answer. So you can dial 0302 211 705 or 06. Again, 0302 211 705 or 706, or more or less the last number 5. Either you make it 5 or you make it 6. Any of them you can call and you can answer questions or ask questions if you think something is not clear and you want more clarification, you can ask me the question, or you are going to answer the next question that will come on our way. And the next question is this one. Somebody will say, hey, but sir, the one you gave us is different from this one. Yes, you can answer, but even I'm going to solve this question with you, and the rest will still come your way. So you can call in if you want to make a contribution. Hello, hello, Evans.
Hello.
Good evening.
Good evening.
How are you?
I'm fine.
Unless you are calling from Takrade, which school?
I'm fine. I'm calling from
Which school? Okay, so let's hear your question, contribution, or answer to the question that I have now. Hello. Yeah, we've missed Evans from Takrade. I'm sure Evans will try again. Please, the moment you call in and we pick your call, you try to lower the volume of your TV set. Try to lower the volume so that we can get you clear. Okay, or maybe before you even make an attempt to call, try to lower the volume of your TV set so we can get you clear. Now, let's look at the solution to this question whilst we wait for those who can call in to bring their contribution or ask questions. Now, for this type of question here, you don't see denominator, right? But there's another unique thing about square root. Anytime you pick square root of a number and the number becomes negative, for example, I get -9. So -9 is going to give you undefined because you put in calculator, you punch negative with -9, it will not give you any answer. It will be a complex number, which we don't want to talk about it now, or imaginary number. And so anytime you have radical or square root, a number that goes under it must be 0 or above. A number must be 0 or above. So square root numbers can be defined if the numbers under it are 0 or above. So we can start by saying that for this function to be undefined, always you try to state your condition of undefined. So for the function, hello. Yeah, how are you?
I'm fine, sir.
Great. Which school are you calling from?
Presbyterian Boys Secondary School.
All right, good. What do you have for us today?
Please, I want to solve the third question.
The third question. Good. That is what we are about to solve. So now give me your version of the solution.
S is such that S is a set of all real numbers.
Okay, I'm writing your answer down so that we analyze and see whether you've gotten it right. S such that S is member of all real numbers.
Where S is greater than or equal to 3.
Greater than or equal to 3. Greater than or equal. That means any number that is less than or equal, that's less than 3, you make it undefined, right?
Yes.
Good. Now, how did you come by the answer?
You will find the root. That is x minus 3 is equal to 0.
Very good. Is it going to be equal to 0?
Yeah, when finding the root, it is equal to 0. But when S is negative, it is undefined. Therefore, you need to find a number which is 0 or greater than 0.
Beautiful. I like it that way. I like it. Oh, that's wonderful. I'm surprised you've been able to give me the answer straight away without even solving example under this aspect of the question. Thank you so much for your answer. I'm sure you have your answers to the question of the day, right?
Yes.
Good. So when it's time, I'll let you come in and then you bring in your answer. Thanks so much for calling.
Okay, thank you, sir.
You're welcome. Oh, so that is his answer. Let's see whether what he said is true or not. Let's see whether what he said is true or not. He said the answer should be S, such that S, member of all real numbers, that S should be greater or equal to 3. Now, I was saying that for the function to be undefined, okay, for this to be undefined, then it means your X minus 3 should be a number less than less than 3. Sorry, less than 0. The moment the number is less than 0, it will be undefined. That is it. I mean, when you do the whole of this, you simplify this, and the result is less than, that means it will be negative. It will be undefined. So if that is the case, we find for the value of X in this inequality, and S is going to give us less than positive 3. So any number less than positive 3 will make the statement undefined. Now let's state our domain. So like he said, it's going to be all real numbers, okay? Then X, if we say X is less than 3, then we say undefined. But then all real numbers with the exception of, so we can say except S is less than 3, which makes his answer. Hello, Akim.
Sir.
Akim, how are you?
I'm fine.
Beautiful, beautiful, beautiful. Thank you for calling. And what do you have for us?
I said, the third question.
The third question, yes.
I said I didn't understand it.
Oh, you didn't understand it? Okay.
Yes.
Okay. Okay. So I'll try to explain it again and again for you to get it. Okay.
Yes.
Yeah. Thanks so much, Akim. I'm going to work on it so that you get it better, right?
Okay.
Good. Good. Thanks so much for calling. Right. So, Hakim, I'll try my best to help you understand it. So, in conclusion to this, before we go over it again, we are saying that S is a member of all real numbers except S is less than 3. That one is except. But then his answer came as, when he said S is a member of all real numbers, S must be greater or equal to 3. That means any number that is 3 or above will make the statement true. But any number that is below 3, that means 3 is not part, below 3 will make it untrue or make it undefined. So his answer is correct. Now let's go over it again for the sake of those who didn't get it. We are saying that anytime you have a number under radical, that number shouldn't be negative. It can be 0. Root of 0 give us 0, no problem. But when it becomes root of negative 2, it's wahala. I mean, to be undefined. And so for this whole thing to become undefined, then the number under radical must be less than 0. So we say for the function to be undefined, okay, X minus 3 should be less than 0. That will make it undefined. So what is your X? X should be less than positive 3. That means all numbers that are less than positive 3 will make it undefined. So we make it exception. So that we say that, okay, then S can be all real numbers. X can be all real except, so you can say except S is less than 3. Or S such that S can be all real numbers, then S should be greater or equal to 3. So these are the two possible ways of writing the domain or element that will make the function define. Right. The next question, yes, if you have an answer to this question, you can call and then tell us your answer. For what value or values of S will make the function undefined? Look at this one. I didn't say defined, I said undefined. That means what are the elements that will rather make it undefined? Meaning, what are the numbers that when you put them into this particular machine, the machine will say na lie, no value will come out. No, 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 no. I won't accept it. What are those numbers? Numbers or number that will make the function undefined. If you have your answer, you can call 0302-211-705 or 706. 0302-211-705 or 6 or 706. Any of these numbers you call, you can bring your answer to this question. For what value or values of x that will make the function rather undefined? What are the values that will make it undefined? I'll give myself few time to relax and wait for you to give me your answer. Call 0302-211-705 or 706. What is your answer to the question? So whilst we wait for your call, we can be step by step unfold the answer to the question until someone tells me, okay, I want to solve the question. Don't solve it, wait. Then I'll give you a chance to give me your answer. For what value or values of x that will make the function undefined? Okay, undefined. That means we say for the function to be undefined, we always set up that premise that for the function for the... Hello, Stephen. Hello, Stephen. Stephen, lower the volume of your TV set. Lower the volume of your TV set so that you can hear you well. Stephen, hello. Hello, Stephen. I think I'm losing. Hello, Stephen. Yeah, it's online. Hello, Stephen.
Hello.
Yes. Which school? Okay. Okay. So do you have answer to this question on the screen?
My answer is X is that. X is the number of real numbers. Except X is one on.
Except S is 1 is equals to what? So what? 1/2. That's half, eh?
Yeah.
Okay. That is Stephen's answer. Okay, so Stephen, thanks so much for bringing your answer. We'll analyze the question and see whether you had it right or not. But before you go, tell me what you did. Oh, sorry, but it's okay. I mean, your answer is okay. We'll look at it and see whether you have it correct or not. The number still remains 0302-211-706 or 705. 0302-211-705, 706. You can call in and bring your answer. Stephen is saying that the answer is S such that S is out of all real numbers except S is equal to half. Okay, here we are looking at the ones whether that will make it undefined, not the domain. Okay, it says what values or what value or values of x that will make the function undefined. So for the function to be undefined, we are saying that for the function to be undefined, then our 2x minus 1 should be equal to 0, because the moment the denominator go to 0, the whole thing becomes undefined. Good. So if you make x the subject, by simplifying this, we get... Hello, Collins?
Yes, sir.
Collins, where are you calling from?
My name is... I'm calling from...
Where? And which school?
John Senior High School.
John Senior High School, right. Okay, so Pope Jones, What do you have for us? Or do you have an answer to the question? Even though you've not finished solving it, I'm sure you can get an answer to this question. What is your answer?
My answer is S is such that S is the number of all values except 1 or 2.
Except 1, S is 1 over 2. Similar to what Stephen gave us. Beautiful. Thank you so much for bringing in your answer. Do you have answer to the problem of the day?
I'm about to say.
Then try and finish it up, because very soon I will give you the opportunity to bring your answer to that question. Good. All right, so let's see whether what you've said is true or not. Let's keep their answers. They all have the same answer. Then we are saying for the function to be undefined, then this must be equal to 0. So we make x the subject and we have our s to be equal to half. Now this half makes the function undefined. So if I say find the element that will make it undefined, then we are going to say s such that s is equal to half. This is what will make it undefined. What they came up with is correct if the question had said defined. So this is a very tricky question. If they had said defined, then you can say all real numbers except. Hello, Rahina.
Hello, sir.
Rahina, how are you?
I'm fine.
Which school are you from?
Almighty
Almighty Busek. Where is it? Where is it located? Oh, okay. All right. So what do you have for us this evening?
X is such that X is equal to 1 on 2.
S is such that S is equals to 1 on 2. Perfect. Why do you think that is correct?
Because it is undefined.
Because it will make the function undefined. Beautiful. Beautiful. Thank you so much, Rahina, too. God bless you for calling. And I'm sure you have the answers to the problem of the day.
Yes.
Good. So when I bring it on board, I will expect you to come out with your answer. Thanks so much for calling.
Thank you.
Great. All right. So let's conclude this part of the question. Then we said S is such that S is equals to half, because that is what will make it undefined. But then if I had said define or the domain, then the answers you brought could have been correct. But for this very question, only what we want is the ones that will make it undefined. Good. So let's take some few general questions. I'll take 1 or 2, then I'll bring the problem of the day. Look at this question here. A function is defined as this, and want to evaluate f of 3. That means when you put negative 3 into the machine, what will be the output? What will be the output? Then again, find the values of x for which this is equal to negative 4/3. Negative 4/3. So in solving this, let's generate this one. To find the value of f of negative 3, just substitute negative 3 into the function, and we have 3 into bracket 3 squared. That means we are putting negative 3 into the function, minus 5 negative 3, and that will give us 3 times 9 minus negative 5 times negative 3 will give us positive 15 here. Then we have 3, 9, 27 plus 15. Answer gives us 30, 42. So that is the f of 3. Then the question said, find the values of s for which f of s, for which the function 3s squared minus 5s is equal to negative 4/3. So that is that. So we just do the simplification, and then you do a normal quadratic function. So when you multiply through by the LCM, you can write 9s squared minus 15x is equal to negative 4. And since it's quadratic, you can rearrange it as this. Hello, Esinam.
Yes.
Isnam, how are you?
I'm fine.
Isnam, thanks so much for calling. And what do you have for us? Do you have solution to the existing question that I'm solving, or you have a question you want to ask?
Yes.
So what do you have for us?
X is that X all over 1 over 2.
Which one are you looking? Are you giving us? Okay, I'm sure you're giving us the previous question that we solved, right?
Yes.
Oh, okay. I'm sure you might have struggled to get your line through so you can give us the answer, but we couldn't call you on time. Sorry for that. Or we couldn't receive you on time. Do you have the answer to the problem of the day that has been advertised already?
No,
Not yet. Okay, so very soon we'll showcase that one for you to solve it and bring out the solution to that question. All right. So here we are. Thank you so much for calling. All right, so let's continue with our solution. 9x squared minus 15s plus 4 is equal to 0. You're going to solve this quadratically to get your answers. So we know that 9 times, first of all, how to solve quadratic function. We know this already. If you do it very well, you should get this as your answer. But then we want to do it using quadratic means. Okay, let me just go quickly to that. So I'll leave this question for you to solve so that we can bring the problem of the day so that we can be very fast. When you do it very well by solving it quadratically, you are going to get either 1/3 or 4/3 to be your answer for the values of x. Good, for the values of x. For the values of x. So let's quickly go on to the problem of the day. Hello. Oh, sorry, we lost him. Let's bring our problem of the day. When I finish and I have time, I will give you more questions to solve on your own. And so let's look at the problem of the day. All right. So our problem of the day says that a function f and j are defined. F is given, j is given, where s is a real number. Then they said f of 1 plus s minus 1 minus 7 equals 0. We want to find the value of x. Then again, we want to evaluate f of negative half times, the dot here simply means multiplication, times j of 3, all divided by f of 4 minus j of 5. So if you have answer to this problem, kindly call and then you mention your name and your school, which I'll record. I want to know those who are going to get it right. Very soon we will start making packages for students who call in to give correct answers. So if your answer is ready for this, let's hear you. Hello. Oh, sorry, we've lost the caller. So the number still remains 0302 211 705 706 0302 211 705 706. Any of this can be used. The last number can be either 5 or 6. Call in, give us the solution to the problem of the day, which is on the screen right now. If you can be so fast enough to use about 2-3 minutes to finish it up, fine. If you answer, but if you already solved it, you call in and you tell us the answers to the question. That's all. Hello, Priscilla.
Hello, sir.
Priscilla, how are you?
I'm fine.
Great. Which school?
I'm fine.
Which school? Which school?
Adventist High.
What senior high?
Adventist Senior.
Adventist Senior High. Oh, okay. Do you have the solution to the problem of the day?
No. The question I don't understand.
You don't have it. Oh, okay. But do you have anything you want to share with us? Maybe a question you want to ask?
I don't understand the question.
You don't understand which one?
The first question.
The question on the screen right now?
Yes.
Don't worry. If you don't understand it, we'll solve it together. Okay? But then we want to find out if people have already solved it, they want to bring out their answers. Then after which we all discuss a solution together. Right.
Okay.
Beautiful.
Thank you.
Thanks so much for calling.
Thank you.
Okay, so Priscilla from Adventist School brought in her suggestion. I mean, she's saying that she doesn't understand the question of the day, so we want to see how we can solve it together and then she'll get it right. Okay, so let's go through the solution. I'm thinking people are still struggling in getting the line through, but since we have some few minutes to go to end today's section, let's see how we can solve today's problem of the day. Hello, Aaron.
Hello, sir.
Hello, Aaron.
Sir.
Yes, which school?
Crystal Palace Preparatory School.
All right. So, what is the answer to the?
My answer is.
Oh, sorry. We've lost Aaron. Aaron has answered. He want to discuss with us. He want to give us his answer, but we've lost him. If your answer is ready, you can bring it. If not, let's start unfolding the solution. So we have, if f of x minus 1 minus 7 is equal to 0, the question has already given us these two functions, right? And the first one says, let's find f of x minus 1. If they had said f of 2, we would have put 2 into the function. But now they said f of rather, pick my pen. Good, got it. So we are going to say f, or rather we are writing the function 2. So we have 2 into bracket x minus 1 squared minus 1, then minus 7, all will give us 0. What do you, Eric? Hello.
Hello, my name is Timothy Adi.
Oh, Adi.
My name is Timothy.
Hello. Okay.
My name is Timothy Adi, calling from Abosu Senior High.
Okay, Abosu Senior High. Okay, that's good.
Yeah.
That's good. So, what are your answers?
Yeah, I have solution to the II.
To the II. And what do you have?
I got negative 11 over 28.
Negative 11 over 28. Okay. That is for the Roman numeral 2. Okay. And what about the 1?
But if I saw with I'm not that.
You're not sure. Okay. That is what we are going through now. So let's go through and see whether you get it right. But then I'm sure, well, I can't tell whether your answer is correct, but I'm sure you are making the way. I mean, let's go through the second part of the question. So the first part of the question together. Okay. So thank you so much for calling and bringing your answer up. Taking note of your name, and when it works for you, sooner or later you hear from us. Right. Thank you so much.
Thank you.
So we are looking at f of x minus 1 minus 7 equals 0. So I'm writing the function f of x. So the function f of x is 2x squared. So whatever I see as, I put in x minus 1, I square it, then I bring my minus 1. That is for this part. Then the whole thing says negative 7 comes equals 0. Right, so this is what we have. 2 into bracket, we try to expand what we have here, which will give us s squared, This will give us x squared minus 2x, then plus 1. Then we bring our minus 1 minus 7 equals 0. We expand the 2 through and we have 2x squared minus 4x plus 2 minus 1 minus 7 equals 0. So this is what we have. Okay. Now we try to simplify further. We have 2x squared minus 4. Now 2 minus 1 minus 7 will be negative 6, right? So x minus 6 equals 0. So this is what we are going to have as quadratic function, also quadratic equation. Then we try solving it quadratically, and to do that we always pick the 2 and multiply by 6 to give us negative 12, and find the factors of negative 12, that when we add we get negative 4, we multiply we get negative 12, and that is going to give us 2 and 6. Hello Simon.
Hello.
Okay, Simon will be our last caller for today. Simon, what do you have for us for the problem of the day?
Please, I.
Yeah.
The
And what do you get for that?
S is negative 1 or S is equal to 3.
Good. Negative 1 or S is equals to 3. And since you are the last caller, I will say yes to your answer because nobody will call again. So your answer is perfectly correct. What about the second one?
The second one, I'm not done with it.
You're not done with it. Okay. The last but one caller gave us the second one to be negative 11 over 28, which is perfectly correct. And then Simon has also given us negative 1 and positive 3, which is also perfectly correct. So when you solve these two, you are going to have the 2, that is the factors of 12 is 2 and negative 6. Now I'm going to do a shortcut. Okay, when you get your 2 and negative 6, switch their signs, switch them, and that will give you negative here, positive here. Divide each of them by the constant term here, that is the a, which will be 2, 2, and when you divide you get neg 1 and you get positive 3. So these are the answers for x. Shortcut. In our next meeting I'll give you detail about how I did this one. So that will give you negative 1 and then positive 3. Then for the second part of the question, you were supposed to simplify this. So what you have to do is that wherever you see f, function f, put in negative half minus 1. Then that of j2 you put in 3 plus 2. Do the same thing for the numerator and the denominator side, and you simplify, you get this answer as that. So we have negative 11 over 28. I'm sure you've learned a lot. You've learned a lot as far as today's program is concerned. Keep watching Joy Learning because we have a lot of packages for you, preparing you for this year's WASI. No one goes in there and struggle. We are all entering WAEC. We go into exams hall, get the best, and then we'll now fly all our results everywhere. It has been with us, that is the revision show for senior high school for the year 2023. And my name is Evans Odei. I've been your facilitator for core mathematics. Thanks so much for watching. Enjoy the rest of your evening.